Hello guys, welcome to this channel. In this channel, I will start discussing chemistry for class 11 and class 12. I hope these classes will be helpful for NEET and JEE aspirants as well. I will start from scratch so that everyone who doesn't have any background or any knowledge on the subject will get clear idea. I'll be teaching both in Bengali and English, so that Bengali medium student from West Bengal also be find it useful. Okay, I'll be starting with a chapter called Thermodynamics or Thermodynamics. Okay, so shall I start? Thermodynamics or Thermodynamics. So, what is thermodynamics? Thermodynamics, by definition, it is a branch of science which deals with transfer of energy. Okay, so thermodynamics, by definition, branch of science which deals with transportation of energy that accompany physical and chemical processes. Okay. So thermodynamics is a Greek word. Thermodynamics comes from Greek words therme, meaning heat, and dynamicus, meaning power or energy. So from etymology we get to know thermodynamics is something which deals with heat or energy. Heat is the mode of transfer of energy. So basically thermodynamics is something which deals with energy. In literal meaning, thermodynamics is something, in little meaning thermodynamics is something which is in motion. Motion, which is thermodynamics is something which is in motion. Dynamics means motion of thermos and heat. So in literal meaning, thermodynamics is something which is in motion of heat, right? So I'll tell a little more about thermodynamics. Why thermodynamics is important. Why thermodynamics is important, or what thermodynamics is concerned with. Okay, thermodynamics কেন ইম্পর্টেন্ট, কেন গুরুত্বপূর্ণ সে নিয়ে থার্মোডাইনামিক্সের ইম্পর্টেন্স এবং লিমিটেশনস সম্পর্কে জানব। ফার্স্ট অফ অল আই thermodynamics is concerned with in chemistry we always encounter chemical reactions, right? Now suppose we have two substances A and B. Let's A and B put together. Let's A and B put together. The two substances, we have two substances A and B. Let's put together A and B. So if we put together the two substances, then will they react? If they react, what energy change will be associated with the reaction. Okay? If they react, the thermodynamics is concerned with whether the substance will react, or if they react, what energy change will be associated with the reaction, right? Now what the thermodynamics is not concerned with? Rate of the reaction. Now to clarify these things, rate of the reaction, right? The thermodynamics is not concerned with the rate of the reaction. Basically thermodynamics तापगतिविद्या is macroscopic, is concerned, is applied, means laws of thermodynamics thermodynamic system or matter in bulk, not the microscopic system. The laws of thermodynamics is applicable in a macroscopic system. Laws of thermodynamics cannot tell what is happening at the microscopic level or atomic level, right? Thermodynamics is concerned with feasibility or spontaneity of a reaction. Spontaneity means the reaction occurs by its own. Okay, so thermodynamics is concerned with the feasibility and spontaneity of a reaction. Thermodynamics can predict whether a reaction can occur on its own or whether a reaction is feasible, whether a reaction is going to happen, right? Thermodynamics cannot tell rate of the reaction. Thermodynamics cannot tell rate of the reaction. It is not applicable. Laws of thermodynamics is not applicable to microscopic system. Right? Now, there is a law. If you, I hope you must be knowing, Gibbs free energy law. Okay? What is Gibbs free energy law? G equals to H minus T S. Now G is Gibbs free energy, H is enthalpy, T is temperature, S is entropy. Or we can write it as delta G equals to delta H minus T delta S. So this change in Gibbs free energy, change in enthalpy, change in entropy. So for a reaction, for a process to occur on its own, the Gibbs free energy must be lowered or reduced. In other words, for a reaction to occur on its own, the Gibbs free energy must be lowered or reduced Okay. In other words, the change in Gibbs free energy must be negative. For a reaction to occur, for a process to occur on its own, the Gibbs free energy must be lowered or reduced, or the change in Gibbs free energy must be negative, right? So this is something thermodynamics. I have mentioned some points on which thermodynamics is concerned with, and some parts, some points, thermodynamics or the laws of thermodynamics is not applicable, right? We'll come to main points. Some terminologies. Used in thermodynamics. Terminologies used in thermodynamics. Terminologies, thermodynamics যে terminologies গুলো used হয় সেই terminologies সম্পর্কে আমরা জানব। First terminology is system, surrounding, system surroundings and boundary. If we consider thermodynamics, in thermodynamics point of view, the whole universe consists of two things. One is energy and another one is matter. This energy and matter make the most of the universe. Okay. Now, if we talk about the matter only, so the matter in thermodynamics can be divided into two parts. Okay, divided into two parts. One is system and another one is surrounding. One is system and another one is surrounding. And there is one thing that separates the system from surrounding, which we will be calling as boundary. Okay? So system, surrounding and boundary. So what is system? System is that part of the universe which is under investigation. Under investigation. Investigation. System. So, what is surrounding? What is surrounding? Apart from system, apart from system, everything outside the system is surrounding. Right? Now what is boundary? Boundary is something that separates system from surrounding. It separates system from surrounding. Okay? Terminology, যেই টার্মিনোলজিগুলো থার্মোডাইনামিক্স কিংবা তাপগতিবিদ্যায় ইউজ হয় সেগুলোর প্রথম হচ্ছে সিস্টেম, সারাউন্ডিং এবং বাউন্ডারি। সিস্টেম, সারাউন্ডিং এবং বাউন্ডারি। তো সিস্টেম কি? সিস্টেম হচ্ছে ইউনিভার্সের সেই পার্ট, ইউনিভার্স বিশ্ব ব্রহ্মাণ্ডের সেই পার্ট যেটা পরীক্ষাধীন আছে, যেটা 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 আলোচ্য, যেটা নিয়ে আমরা আলোচনা করব বা আরো বিস্তারিত জানতে পারবো সিস্টেম, সারাউন্ডিং এবং বাউন্ডারি সম্পর্কে। সারাউন্ডিং কি? সিস্টেম ছাড়া সিস্টেমের বাইরে যা কিছু আছে সেগুলো হচ্ছে সারাউন্ডিং। বাউন্ডারি যেটা সিস্টেম এবং সারাউন্ডিংকে আলাদা করে। নাও assume a container, assume a container containing some liquid. Okay, suppose this container, the content inside the container or the liquid has a temperature of 50 degree centigrade. We want to raise the temperature to 100 degree centigrade, right? We want to raise the temperature to 100 degree centigrade. Now, to raise the temperature, we need to supply heat. We need to supply some heat. Let's say a Q amount of heat is required. Now, by definition, we can call this content, the content inside the container is system, because it is our investigation. We have to experiment something. Okay, we have to experiment something, or we have to investigate something. So this part of the universe is our investigation for the time. Okay, তো একটা কন্টেনার যার মধ্যে একটা লিকুইড আছে, যার টেম্পারেচার আছে ইনিশিয়াল টেম্পারেচার 50 ডিগ্রি, আমরা 100 ডিগ্রি পর্যন্ত বাড়াতে চাই, কিছু পরিমাণ তাপ আমাদেরকে দিতে হবে। তো এই যে পার্টটা, এটা সিস্টেম মানে গোটা ইউনিভার্সের মধ্যে, এটা আমাদের এখন পরীক্ষাধীন আছে। তো এই বাই ডেফিনেশন সংজ্ঞা, যে সংজ্ঞা অনুসারে এটা আমাদের যেহেতু পরীক্ষাধীন আছে, তাহলে আমরা এটাকে সিস্টেম, ঠিক আছে। এবার এই সিস্টেম এর বাইরে, এই সিস্টেমের বাইরে যা কিছু আছে, apart from the system, everything outside the system is surrounding. এগুলো হচ্ছে সারাউন্ডিং, এটা হচ্ছে সিস্টেম। ওকে, the content inside the liquid inside the container is system. Now the apart from the system, everything outside the system is surrounding. Now there is something which separates the system from the surrounding, which we will be calling as boundary or wall. So this is boundary or wall, right? So this part is separating system from the surrounding, right? So up to this point I think everything is clear. এখন পর্যন্ত এইটুকু আমি মনে করি পরিষ্কার। Okay, now I will discuss system, surrounding and boundary a little bit more details. Okay, first I will discuss boundary. Okay, now you know boundary is something which separates system from the surrounding, right? Boundary is something which separates boundary is something it separates system from surrounding. Now boundary is imaginary boundary, another one is real boundary. Okay, so let's discuss bit more details. So again we have taken a container containing some liquid. So inside the container, this is our system, right? This is surrounding, and this is wall or boundary. Boundary, right? Now boundary can be real or imaginary. Now real boundary again can be of two types. One is diathermic, another one is adiabatic. Right? One is diathermic, another one is adiabatic. First of all, I will discuss real boundary. Now, diathermic. What is diathermic boundary? Now, if the boundary is made up of something, means some conducting material, then it is sealed but not insulated. What is insulated? What is insulated? Insulated means something, some special material which prevents exchange of energy. Okay. So diathermic boundary is something which allows transfer of energy from system to surrounding and from surrounding to system. Okay, so this type of boundary allows passage of energy. Diathermic boundary allows passage of energy, not mass. Okay. An adiabatic boundary neither allows passage of mass nor energy from system to surrounding or from surrounding to system. Okay. So diathermic boundary, if the boundary is made up of some conducting materials, means thermal conducting materials, then it will allow transfer of masses from system to surrounding and from surrounding to system. Okay. But if the boundary is made up of some special materials, some insulating materials, then it will neither allow passage of mass nor energy. So this type of boundary, which we will be calling as adiabatic boundary, if it allows transfer of energy from system to surrounding or surrounding system, then we will be calling as diathermic boundary, right? So boundary হচ্ছে দুই ধরনের, একটা হচ্ছে ইমাজিনারি, একটা হচ্ছে রিয়েল। এটা হচ্ছে রিয়েল বাউন্ডারি হচ্ছে দুই ধরনের, ডায়াথার্মিক যেটা এনার্জি সিস্টেম থেকে সারাউন্ডিং এবং সারাউন্ডিং থেকে সিস্টেমে ট্রান্সফার অ্যালাউ করে। অ্যাডিয়াবেটিক বাউন্ডারি হচ্ছে যেটা সিস্টেম থেকে সারাউন্ডিংয়ে এনার্জি কিংবা মাস কোনোটাই ট্রান্সফার অ্যালাউ করে না, সেটা হচ্ছে অ্যাডিয়াবেটিক বাউন্ডারি। ঠিক আছে। নাও হোয়াট ইজ ইমাজিনারি বাউন্ডারি? ইমাজিনারি বাউন্ডারি, নাও in this system, if we heat the system, right? We heat the system. Then at a certain point, when the liquid inside the container starts evaporating, so at this point there will be vapor phase above the liquid. So here it will be vapor, right? And it will still liquid. In the vapor and liquid there will be a imaginary line, okay, which we cannot see by our naked eyes. Okay, so this type there will be boundary, there will be a boundary which we cannot see by our naked eyes. This type of boundary we will call it as imaginary boundary. Imaginary boundary, right? তো যদি আমরা লিকুইডটাকে গরম করি, তাপ দিই, তাহলে যখন ও স্ফুটনাঙ্কে পৌঁছে যাবে কিন্তু ভেপোরাইজেশন হবে, তখন লিকুইড এবং ভেপারের মাঝখানে কিন্তু এমন একটা লাইন, যেটা আমরা খালি চোখে দেখতে পাবো না, এরকম একটা বাউন্ডারি কিন্তু বাউন্ডারি অস্তিত্ব থাকবে। সেই এই ধরনের বাউন্ডারিকে আমরা কিন্তু ইমাজিনারি বাউন্ডারি। ঠিক আছে, আমার মনে হয় বাউন্ডারি কনসেপ্টটা ক্লিয়ার হয়েছে। Now coming to system again. Now coming to system again. So system, what do you know? What is the definition? That what is the definition of system? That part of the universe which is under investigation. Investigation. তো সিস্টেম হচ্ছে বিশ্ব ব্রহ্মাণ্ডের সেই অংশটুকু যেটুকু নিয়ে আমরা আলোচনা করি, যেটুকু আলোচ্য, সেটাই হচ্ছে সিস্টেম। সিস্টেম কিন্তু লাইক সিস্টেম আবার তিন ধরনের। সিস্টেম is of three types. System is of three types. One is open system, closed system, and isolated system. Okay, isolated system. Closed system, open system, and isolated system. System तीन प्रकारेर, এটা হচ্ছে open, closed, and isolated. I'll discuss these points a bit more. As we discussed earlier, this is our container containing some liquid. So content of the container is our system. So this liquid is our system for the timing. Now suppose at this point if we supply heat, Q amount of heat, then when the liquid starts evaporating, then since the upper portion is open, the energy as well as mass will transfer from the system to surrounding, right? So energy plus mass, since the system is open, if we supply heat, then at a certain point or after a certain point, there will be exchange of heat and mass between the system and surrounding, right? So this type of system, which we will be calling as open system. Transfer of mass and energy takes place. So in open system, transfer of energy as well as mass takes place. In closed system, now if we put a lid at the top of the container, then whether this system will allow transfer of mass between the system and surrounding, whether this mass will go out from the system to surrounding. No. Here in this system, if the wall is made up of diathermic material or thermal conductive material, then the system will be sealed only to prevent transfer of mass from the system to surrounding. But here the system will allow to transfer the energy from system to surrounding and surrounding to system. So here the exchange of energy takes place between the system and surrounding. So closed system, in this closed system, exchange of energy takes place, not mass. So in closed system, the closed system allows transfer of energy from system to surrounding and surrounding to system, but not the mass, right? So exchange of energy, only energy is allowed to exchange between the system and surrounding. In isolated system, like adiabatic boundary, if the boundary is made up of insulating materials, then there will be no transfer of mass or energy takes place between the system and surrounding, right? So this type of system, neither isolated system, it neither allows transfer of mass nor energy, right? So open system, transfer of mass and energy takes place. Closed system, exchange of energy takes place, not mass. Okay. Isolated system, it neither allows transfer of mass nor energy. Okay. So I think the open system, closed system, and isolated system, these three types of systems are clear to all of you. তো সিস্টেম হচ্ছে দ্যাট পার্ট অফ দ্য ইউনিভার্স, মানে ওই ইউনিভার্সের সেই অংশটুকু যেটুকু হচ্ছে আমাদের পরীক্ষাধীন আছে। সিস্টেম তিন প্রকারের: ওপেন সিস্টেম, ক্লোজ সিস্টেম, আইসোলেটেড সিস্টেম। ওপেন সিস্টেমে হচ্ছে মাস এবং এনার্জি দুটো ট্রান্সফার, মানে সিস্টেম এবং সারাউন্ডের মধ্যে এক্সচেঞ্জ হয়ে থাকে। ক্লোজ সিস্টেমে এক্সচেঞ্জ অফ মানে শুধুমাত্র এনার্জির এক্সচেঞ্জ হয়ে থাকে, কিন্তু মাসের না। কারণ সিস্টেমের বাউন্ডারিটা শুধুমাত্র সিল থাকে কিন্তু ইনসুলেটেড না। সো সিস্টেমস বাউন্ডারি ইজ অনলি সিল বাট নট ইনসুলেটেড ইন ক্লোজ সিস্টেম। আইসোলেটেড সিস্টেমে সিস্টেম বাউন্ডারি সিল থাকে এবং ইনসুলেটেড থাকে। সো দেয়ার is no transfer of energy as well as mass. Okay, so isolated system e energy এবং mass কোনোটারই ট্রান্সফার হয় না। A system based on composition system can be classified. System can be classified as homogeneous and heterogeneous as well. Based on composition, system can be divided into two parts: homogeneous and heterogeneous. Homogeneous system, heterogeneous system. What is homogeneous and what is heterogeneous? If the property or this is a system, so the property of the system is uniform throughout. Okay, means the property is equal everywhere. If the property is equal everywhere, the mixture is uniform. The gases or ideal gases, if the mixture is uniform everywhere, then this type of system will be calling as homogeneous system. Now, if the system is not uniform everywhere, then this type of system will be called as heterogeneous system. Homogeneous system means like air. Air is a mixture of many gases, right? So air is an example of homogeneous system. Now, what is heterogeneous system example? Heterogeneous system can be some solid particles in contact with gases. So there will be two phases: some solid in contact with gases, some immiscible liquid with some immiscible liquid means some oil. If oil is in contact with water, then this will not make a heterogeneous mixture, right? This will not make a homogeneous mixture. This is an example of a heterogeneous mixture. So the property is not equal everywhere. For heterogeneous mixture or heterogeneous system, but in homogeneous system the property is equal everywhere. So based on composition, system is homogeneous and heterogeneous, right? Composition এর ভিত্তিতে সিস্টেম হচ্ছে হোমোজিনিয়াস এবং হেটেরোজিনিয়াস। হোমোজিনিয়াস এটাই যেটা সব জায়গায় সব জায়গায় মিক্সচার কিংবা প্রপার্টি সমান থাকবে, ইকুয়াল থাকবে, হেটেরোজিনিয়াস সমান থাকবে না, ইকুয়াল থাকবে, আলাদা থাকবে। সরি, সিস্টেম সারাউন্ডিং বাউন্ডারি হলো দ্বিতীয় নম্বর। হচ্ছে thermodynamic properties. Thermodynamic properties. The thermodynamic properties are of two types. One is extensive property, another one is intensive property. Extensive property. The extensive properties are those whose magnitude depend on the quantity or amount of mass. Properties whose magnitude depend on the amount or quantity of matter or substance, right? So this type of properties is called extensive property. The extensive properties are those whose magnitude do not depend upon the amount or quantity of the matter or substance, right? So extensive property is সেই প্রপার্টি যার ম্যাগনিটিউড পদার্থের পরিমাণ এর উপর নির্ভর করে, সেগুলো হচ্ছে এক্সটেন্সিভ প্রপার্টিজ। ইন্টেন্সিভ প্রপার্টিজ হচ্ছে সেইগুলা যেগুলো হচ্ছে ওর ম্যাগনিটিউড পদার্থের পরিমাণ বা কোয়ান্টিটির উপর নির্ভর করে না। এক্সাম্পল হচ্ছে এটা এক্সটেন্সিভ প্রপার্টির এক্সাম্পল হচ্ছে ভলিউম, ভলিউম, মাস, হিট ক্যাপাসিটি, মোলস, internal energy, enthalpy, entropy, gives free energy. Gives free energy. So these are the extensive properties. Now example of intensive properties: temperature, pressure, boiling point, melting point, density, specific heat capacity or specific heat. Specific heat, specific heat, molar, molar heat, molar entropy, molar enthalpy, molar enthalpy, refractive index, dielectric constant, dielectric constant, and so on. So these properties do not depend upon the its magnitude do not depend upon the amount or quantity of the matter, right? So extensive properties হচ্ছে যে properties যার ম্যাগনিটিউড পদার্থের পরিমাণের উপর নির্ভর করে না। উদাহরণ হচ্ছে ভলিউম, মাস, নির্ভর করে। উদাহরণ হচ্ছে ভলিউম, মাস, হিট ক্যাপাসিটি, মোলস, ইন্টারনাল এনার্জি, এনথালপি, এন্ট্রপি, গিভস ফ্রি এনার্জি। ইন্টেনসিভ প্রপার্টিজ সেইগুলা যার ম্যাগনিটিউড পদার্থের পরিমাণ এর উপর নির্ভর করে। নির্ভর করে না। টেম্পারেচার, প্রেসার, বয়েলিং পয়েন্ট, টেম্পারেচার মানে হচ্ছে তাপমাত্রা, চাপ, বয়েলিং পয়েন্ট স্ফুটনাঙ্ক, ডেনসিটি ঘনত্ব, স্পেসিফিক হিট আপেক্ষিক তাপ, মোলার এন্ট্রপি, রিফ্র্যাক্টিভ ইন্ডেক্স, ডাইলেকট্রিক কনস্ট্যান্ট, এগুলো হচ্ছে ইন্টেনসিভ প্রপার্টি উদাহরণ। Some characteristic properties. I'll be discussing some characteristic properties of intensive and extensive properties. Okay. Extensive, intensive. Extensive and intensive. Extensive properties are additive in nature. What actually it means, I'll tell you. Okay. Suppose, again we are assuming a container containing some water. Let's say it's 1 liter. 1 liter of water. 1 liter water. Okay. Now we we're taking another container containing the same amount of water, means it is also 1 liter of water. Now if we add them in a third container, then what will be the final amount of water? That will be 2 liter, right? The final volume of the water will be 2 liter, right? 2 liter water. Now 1 liter, we know the density of water, it's 1 gram per cc, right? So the weight will be 1 kg of water, 1 kg. So the weight will be 2 kg. When we will add them, right? We'll add them. The mass will be 2 kg. The volume will be 2 liter. Volume 1 liter. Mass M1 1. Mass M. Mass M 1 kg. Volume 1 liter. So the volume getting added after it is added, right? Volume and mass getting added. So these properties are additive in nature. So what is volume and mass? They are extensive properties. So they are additive in nature. Now, if the temperature of the container 1 is 50 degree, right? And it is also 50 degree. If we add the water to container, if we add the water of the two container in third container, whether the temperature of the third container will increase or decrease? No, the temperature will remain constant to 50 degrees, right? The temperature will remain 50 degrees centigrade. 50 degrees centigrade. So this will not change. Whether the density will change? No, the density will also not be changed as well. So the intensive properties are not changing, but extensive properties will be getting added, right? After adding it. So they are additive in nature. যখন আমরা এই দুটো কন্টেনারকে অ্যাড করছি, ভলিউম মাস দুটো অ্যাড হচ্ছে, ভলিউম মাস কিন্তু এক্সটেন্সিভ প্রপার্টিজ আর অ্যাড হচ্ছে, সো দে আর অ্যাডিটিভ ইন নেচার। ইন্টেন্সিভ প্রপার্টি যেমন টেম্পারেচার কিংবা ডেনসিটি, এগুলোকে যদি দেখি তাহলে এরা কিন্তু সেম থাকছে, ঠিক আছে? এটা অ্যাডিটিভ ইন নেচার না। Division of an extensive property by another extensive property gives the resultant property makes the resultant property gives the resultant property intensive. Okay, division of an extensive property by another extensive property gives the resultant property, makes the resultant property intensive, right? Now suppose we have taken 1 liter of water in one container, 1 liter of water in another container. Now mass of this water is 1 kg and 1 kg, right? So if we divide mass by volume m by v, this will make density, right? So density is the intensity property, we already know that. So the density is intensity property. Likewise, if the heat capacity of this water is Q, right? If capacity of the water is Q, if we divide it by number of moles, and if we divide it by number of moles, then the resultant property will be molar heat, right? Molar heat will be intensive property. CM will be an intensive property. So division of an extensive property by another extensive property yields the resultant property intensive. Right? So I think up to this point everything is clear. এখন পর্যন্ত এইটুকু পরিষ্কার, right? Now we'll be talking about thermodynamic parameters. State functions. Or state variables. So thermodynamic parameters or state function or state variables, there are some fundamental properties which determine fundamental properties. There are some fundamental properties which determine the state of a thermodynamic system. Okay. Now those parameters are called state functions, state variables, or thermodynamic parameters. Okay. The example of the thermodynamic parameters for state functions are temperature, pressure, internal energy, gives free energy, gives free energy, enthalpy, etc. Okay, entropy, so for a system, these are some fundamental properties, thermodynamic parameters which determine the state of the system. Suppose the temperature 61, pressure P1, pressure P1, volume V1, internal energy U1. Okay. Now, if we change any one parameters of the system, the overall state of the system undergo thermodynamic changes. Okay. So, any one change, or in other words, we can say that the system can be, the state of the system can be changed from one state to another by means of changing temperature, pressure, volume, internal energy, etc. Okay. To change the state of the system, we can take several paths. Okay. Now, in state functions or state parameters, the system depends only the initial and final state, not on the manner on which, or not on the path through which it is not on the manner in which it is undergoing, okay, or not on the path through which it is undergoing. So it does not, state function does not depend on the path through which it is taking place or through which it is taking to. So it depends only the change in state, the state parameter, the change in states, the state functions, change in state depends on the state, final state minus state, initial state. Okay. Now I will discuss a bit more in the next class. For this class, I am ending this session for now. Okay. I'll be meeting you soon in the next class. So till then,